Hi everyone, as you can see, this is me, Arthur, and Hanners. Today we're working on presenting to you the unit circle and trigonometric derivatives and
problems involving trigonometric derivatives in the second half of the video.
Yep, so we're going to begin with the unit circle right here, as you can see on the on-screen video. And the unit circle is basically a circle with a radius of 1 and a center at 0, 0 on the Cartesian plane. All you have to do to understand the unit circle is think of the sine and cosine functions as points for the unit circle given argument. So say there's 30 or 30 degrees or pi over 6 in the first one. You can think of the cosine function as the x and the sine function as the y. So square root of 3 over 2 is the solution to that cosine, the cosine of pi over 6 or 30 degrees, and the sine function solution is 1 over 2 at that point. As cosine functions increase in magnitude, the sine functions decrease in magnitude, and vice versa. So we'll do a quick read off of all of the cosine and sine point values with the given argument, just so to give you an audible understanding of it, and then we'll move on to the derivatives.
Problems.
Exactly. So 0 degrees is obviously 1 because it's the maximum cosine, and 0 because that's the minimum sine. 30 degrees, or pi over 6, is square root of 3 over 2, and then 1/2. 45 degrees is pi over 4, square root of 2 over 2, and square root of 2 over 2. The two are equal at that point. 60 degrees, pi over 3, 1/2. The sine of that is 1/2, and the sine of it is square root of 3 over 2. Moving on, the 90 degrees is the transitionary point, so obviously it's the maximum sine and the minimum cosine. The second quadrant, it's basically the same thing, except cosine is negative. And Hannah, in the third
quadrant, sine and cosine are negative, and in the fourth quadrant, only sine is negative and cosine is positive.
Yep. So now we can move down the screen onto our favorite derivatives. Now you have to understand these for the test. They're very important, and they're even more important on the AP exam. So if you want to do well, pay attention. The derivative of sin is cos. The derivative of cosine is negative sine. The derivative of tangent is secant squared.
The derivative of cotangent is negative cosecant squared.
The derivative of secant is secant x times tangent x.
The derivative of cosecant is negative cosecant times
I highly
cotangent.
suggest reviewing these for the test because they'll be very important. You won't want to have to derive this and waste time in the middle of the test.
Flashcards are definitely a good idea here.
Digital flashcards.
So, in this second part of the video, we will be finding the derivative of this equation, f of x equals cosine of x over 1 plus the sine of x. So, the first step is to use the quotient rule to find the derivative, and then from there you simplify. And we have the steps laid out just so the video can be quicker, and I'll go through the steps. So the quotient rule is low d high minus high d low over low squared. So first you take the denominator and multiply it by the derivative of the numerator. Thank you, Arthur. And you subtract from that the numerator times the derivative of the denominator, and you divide everything by the denominator squared. So in the second step, while you're simplifying this big derivative here down to the smaller version of the derivative, you distribute the derivative of cosine of x, which we know from the chart above is negative sine x, and you multiply that by 1, so that's just negative sine of x, and you also multiply it by distribution by sine of x to get negative sine of x squared x. And then you find the derivative of 1 plus sine of x, and since the derivative of 1 is just 0 because 1 is a constant, and then the derivative of sine x is just cosine x, again by the chart above. You multiply that by cosine of x, so you have in total for the numerator negative sine x minus sine squared x minus cosine squared x. Then you keep the denominator the same because you aren't simplifying that yet. In the third step, you use a trigonometric identity. Remember these for the test. Sine squared of x plus cosine squared of x equals 1. So you put that in parentheses to designate that's a quantity, and you have negative sine of x minus the quantity sine squared of x plus cosine squared of x over the denominator that we've had all along, the quantity 1 plus sine of x squared. Then in the next step, you simplify the numerator into negative sine of x minus 1 because this is a trigonometric identity which equals 1. And you keep the denominator. And then in the second to last step, you factor out a negative to get negative quantity 1 plus sine of x over the quantity 1 plus sine of x squared. And then since the numerator cancels with the denominator, you get negative 1 over 1 plus sine of x.
And then you're done with that problem.
Yeah, that's right. Thank you, Arthur.
Now for an equation of line perpendicular to the graph of
y equals tan x over 1 plus tan x at x equals 4. So this incorporates a bunch of stuff that we've learned. So both finding the derivative and,
making a tangent line and then finding a perpendicular line or whatever you want. Whatever you like.
It's an extensive problem, so it'll take a while, so sit tight, guys. So in the first step to finding the derivative of the function, we will use the quotient rule. So that's low d high minus high d low over low squared. So the denominator is 1 plus tan of x, and so you move that to the numerator of the derivative, and you multiply by that by the derivative of the numerator, so the derivative of tan x. And then you subtract from that the numerator, tan of x, and you multiply that by the derivative of the denominator, so the derivative of 1 plus tan of x. And you divide all of that by 1 plus tan of x squared. And then you simplify in the second step. So 1 plus tan of x times the derivative of tan of x, which is secant squared of x, minus tangent of x times the derivative of 1 plus tangent of x, which equals tangent of x times 0 plus secant squared of x. Of course, the derivative of a constant is 1, so that's why that ends up being 0. And the derivative of tan x is secant squared of x. In the third step, you distribute secant squared of x into the quantity 1 plus tangent of x. So that simplifies down to secant squared of x plus secant squared x times tangent of x minus tangent of x times 0, which is 0, and then tangent of x plus secant squared of x, which is secant squared of x times tangent x, of course, and you keep the denominator the same.
And magic! Here I am! I've replaced Tanner for the remainder of the presentation with this problem, and it's just magic how I got here. So, moving on, sec squared of x over 1 plus tan x squared, obviously the 1 plus tan x squared is in parentheses. It can be simplified down to have the actual value that you're trying to put in for the y prime function. So a secant squared pi over 4 over 1 plus tangent squared, tangent pi over 4, all in parentheses and then squared, and which then simplifies down to simply square root of 2 squared over 1 plus 1 squared, because tangent of pi over 4 is 1. And moving along, there appear tenders! And there's tenders! Moving along, it's just 1 over 2. That just means that the slope that we want perpendicular to that slope will be m equals negative 2 moving on, we have the point that we were given, pi over 4 and 1/2, and we can plug that into y minus y1 equals mx minus x1.
Yeah, so it's in point slope form and everything. You could
Put it in
y equals
slope
that,
intercept 4.
Yeah.
Yeah.
Yeah. And of course that has the inverse slope because it's perpendicular.
Right.
Negative inverse, excuse me.
Yep.
Yep.
So, if you guys have any questions at all or on understanding any of this stuff, feel free to message me through shunderpooch@gmail.com. I'll be happy to answer any questions that you may have. I'll obviously share this document with all of you. Have a great night, everyone. Best of luck studying for your calc exams, and love you all.
Bye.